In this video, I'm going to talk through how I would answer part 2 of this achievement standard here, which has been made available by NZQA on this website here. So I'm looking at 3.2b. This is a theory task, so having read it, I've also looked at the two chemicals I'm going to have to tell apart and explain how I'd use spectra to do that. It's easier to just look at the pictures of those than to draw them out. So here I have got pentanoic acid, which is one of the two chemicals that it could be, and here's ethyl propanoate, which is the other one that I've said that it could be. So I'll be referring to these every now and then as I work through the answer. So here it says you've been asked to analyse a product of chemical synthesis. We know that its empirical formula is this. So, and we are told that it could be ethyl propanoate or pentanoic acid. So my first thing would be to draw both of those and show every chemical bond, so I can see what fragments would be made in mass spec, and also so I can start seeing similarities and differences between them. So if I do have a look at them very quickly, I can see that they've both got a CO double bond in them, so I'd expect that to be pretty similar in infrared. They also have CO single bonds in them, so that's probably going to be quite similar. However, what's different is that the pentanoic acid has an OH, which the ester does not. So I could expect a different peak in there. I know because they've got the same molecular formula, they're going to have the same molar mass. I need to be explicit in saying this, though, when I do actually answer this question. So I've had a look at them and I've seen one major difference. This OH, which is going to have show a difference. The other thing I'm going to quickly look at is for any symmetry. What I actually find when I look at this is that each carbon is unique in the ester. So this will give 5 peaks in carbon-13 NMR. Unfortunately, all of these are unique as well. So therefore, this carbon is bound to a CH2. This CH2 is bound to two other CH2s. It's bound to a CH3 and a CH2. This one is bound to two CH2s, and so on. They're all unique. So therefore, I can't really use NMR at all. Again, as part of my answer, I want to explicitly say that both would give 5 peaks, so therefore this can't be used. That's what makes it a discussion rather than just an explanation. So here goes. How am I going to use different ways to do it? So I'll type in blue so you can see my answer a bit more clearly. The first thing I'm going to say is that I'm going to talk about infrared because I think the IR is going to tell us the most. So I'm going to say pentanoic acid would have a broad stretch around, we'll say 3500 cm-1, indicative of an OH bond. This would not be present in ethyl propanoate. Right. Yeah, by the way, we would also expect propanoic acid to have a strong peak at 1725. Remember, you're given the data for this. You don't have to remember these values off by heart. That's also due to the OH. All right? Sorry. Yeah, 1725 to 1750 for CO. Alright. The ester, so ethyl propanoate, would have a strong peak around 1750 due to the CO bond, much like the acid. Okay, so to say we're comparing here, they're pretty similar. But it would also have a peak around 1200 due to the CO double bond, which the acid doesn't have. Okay, so here I've not just explained, I've discussed it. And as a hopefully clear enough to imply, I would draw both of these in so I could show the examiner that I know what I'm talking about. I've drawn both structures first, so I'd put those in first. Alright? Okay, I've looked at IR. I can't just look at IR. I'm now going to look at mass spec. Whoops. Okay, with mass spec, as the two compounds are isomers, they would have the same molar mass. Alright? Therefore, they would both have a peak at, now we're trying to remember this, that's 102 for those, okay? Because their molar mass equals 102 grams per mole. Alright? However, if I look at the two structures, there's quite a clear difference. Whoops. And if you think about the fragments that these would make, this one here is going to make a CH3, CH2, CO fragment that cannot be made by this one here at all. It cannot be made. So what I'm looking at is this unique fragment here, CH3, CH2, CO, and work out its molar mass. So 12 plus 12 plus 12 plus 16 plus 1 plus 1 plus 1 plus 1 plus 1 is 57. So it's going to have a peak at 57. This one is not going to have a peak at 57. So that's another way that I could use mass spec. So ethyl propanoate have a peak at 57 MOZ due to the CH3, CH2, CO plus fragment, and pentanoic acid would not have a peak here in its spectrum. Alright, I'm doing pretty well here. I've actually justified why it is, how I'd use this. The last thing I am going to say, and remember I said they both have five unique carbon environments. So I'd probably circle those in my spectra. And I'm going to say this could not be used to distinguish between these isomers, as both have 5 unique carbon environments. So we both have 5 peaks. I mean, this is the other that you could throw in there, is they both contain a carbon-oxygen double bond. They would both have a peak downshifted. Sorry, that's not the way to phrase this. How do I phrase it? Have a peak in downfield shift position. That's a good way to phrase it. So you can't even use it to try and find the CO double bond, which should be downshifted. So I've said there that it's useless, basically. Now, because I've not just explained how I've said it or identified a couple of things that I'd expect to see, I'd expect to get my evidence for excellence in here, because I've discussed it. I've discounted using NMR. I've talked about mass spec having that unique fragment, and that's probably a very key one. And I've talked about how the IR would be quite different. The IR is probably the most useful there. So hopefully that helps you answer part 2 of this. And in the next video, we're going to be looking at task 3, which is the last of our tasks in this whole assessment.